Okay, where do we leave off with worksheet 1? 8.
Don't worry.
Okay, so number 8, you're going to fill out your flow field.
Oh, yeah.
Okay, so go ahead and see if you can fill out your slope field. You're only filling out a potential slope field segment through the identified order pairs. Okay. And so really, you're really just making sure that you know to put a positive slope, a negative slope, a slope 0, or undefined. So if something is meant to be undefined, you don't put a vertical line there, just leave it blank. Okay. So you get an undefined slope, do not do anything through that point. Okay. So here we have eight order pairs. So you're either positive slope, negative slope, 0 slope, or nothing. And then part B is asking for a particular solution to the differential equation. So you're going to go through your steps of separating your variables, taking antiderivative. Once the plus C shows up, then you have 2 things left to do. You want to be able to solve for C and then solve for Y. Okay. The order doesn't matter. Sometimes I do one before the other, depending on which one I feel is the easier step to go through. So that's just, whatever you want to do. But that also means that our C values may not agree, but it's okay because when we solve for Y, we should end up being having the same equation. And then part C says write the tangent line of the equation to the curve at 1, -1. So this should feel easy because all you're doing is taking your order pair, plugging into the derivative to get your slope. Once you build your tangent line equation, then it's just a linear approximation. Then you're just inserting 1.2 in for x. So you'll get to use your calculators on your quiz on Friday. So feel free to use your calculators, but I also want to see your work. Okay, all right, so try number 8. I'll go through the problem with you, but you guys also have the key to allow you to check your answers and work ahead if you like. But I also want to walk around and see if there's any questions that you want me to, they have for me. This one I'll leave for both. I keep thinking after a while. I know, yeah. I want to make a distinction here. Whenever you see 1 over x, right, this is natural log. Right, but if it's any other power, what do we do? It's power rule, right? So that's something that we kind of get used to because we see so much of this that we feel like, oh, it's gonna be natural log for anything here, but that's only for one case, right? Every other case, you got to bring it up to the top and go through power rule. So yeah, just keep that in mind, right? That's that you don't automatically assume that every variable in the denominator means natural log. Depends on what the power is. Okay, so product, my dy dx's are in the right places, but the variables are not quite separated. So I did a double division here. Move the y squared to the denominator of the left side, move the x to the denominator of the right side. Left side is power rule, the right side is natural log. And then after you find your antiderivative, then it's up to you what you want to do. You want to solve for c first, you want to solve for y first. I figured y is in a strange spot here. I'm going to just quickly solve for c. Once I solve for c, then it feels a little bit clearer. I can just cross multiply in a way where I can eventually get that y by itself. Let me just talk a little bit about the scoring on the AP exam, especially with these differential equation problems. If you can separate the variables, that's usually like 1 or 2 points. Being able to find the antiderivative, that's another 2 or 3 points. And then solving for c, that's 1 point, and then solving for y, that's 1 point. So sometimes a problem is just a really messy process to get to solving for y. So on the AP exam, it's like, you want to try your best here, but if it's only 1 point and you've already earned everything else, it's almost not worth the effort to spend 5 minutes on just trying to solve a y when there's other things to work on. Just want to point out that sometimes this is the hardest part of the problem, but it's the least important part. It's not as important as separating variables and actually finding the antiderivative. That's the most important part. And then the solving for c and solving for y are they're both worth 1 point, but they're not as important as the previous steps. Okay, part C should feel pretty easy, hopefully. In the past, I would see some students try to separate the variables and try to find it. So this is part C shouldn't feel. We shouldn't deal with a whole lot of messiness with part C, right? You're just using the derivative just to get to the slope, right? You're not having to solve the differential equation. So hopefully we don't kind of merge this step into part C, that we recognize this is a relatively easy step here, and that we don't overdo it. Okay, any questions? Okay, for number 9, really, you're just trying to figure out a way to, you're going to solve for k, but what you're going to do is you're first going to find y prime, then find y double prime, and then with your y prime, y double prime, you can insert into the differential equation, and then see it algebraically if you can figure out a way to solve for k. Remember, k is only a constant, so there's no need for a product rule here. K is just a number in front. So what's the derivative of cosine u?
Negative sine.
Yeah, negative sine u times u prime. What's the derivative of sine of u? So cosine u times u prime, right? So go ahead and find your second derivative, and then you can insert into the equation, and then you're just trying to figure out how can I solve for k. Right. But yeah, with all these verifying problems, you're just finding y prime, y double prime, and then the rest is just substitution in algebra to kind of figure out whatever they're asking you to solve. Okay. So, and then same with 10, same with 11. Hopefully you don't find those difficult. They're just having to.
So for that 16y number 9, I can just substitute the original.
That's right. Yeah. Substitute your original equation. And this one is not asking for y prime. The only thing you need with y prime is to get to y double prime, but doesn't require it. But yeah. But a bunch of things cancel out, which is good. The signs will go away, leaving us relatively easy ability to get that k by itself.
If you get done with 9, let's skip 11 and 12. I feel like those are just the same procedure. And let's go to 12. See if you can fill out your or match your slope field with either the equation or with the differential equation. If you're matching with the differential equation, then you got to look at each of the slope behavior, like, oh, where's the collection of positive slope? Where's the collection of negative slope? But for for number 1 and 4, if you're trying to match with the original equation, then you got to look at the shape, right? So whatever the shape looks like, that's what you're trying to match with. Okay, so let's skip 10 and 11 for now. If you feel okay with 9, you can always go back and practice 10 and 11 on your own. But those are just same process. So number 12, it says slope field from a certain differential equation is shown for each problem. The multiple choice answers are either differential equation or a specific solution to that differential equation. So here, these are all y equals. So and if you look at your curve, this looks most like a natural log graph, right? So that makes sense that, and if you look at number 4, right, you look at that pattern of the graph here, this resembles like a cubic function. So 4 fits the shape of D the best. For 2 and 4, though, we have to look at the collection of slopes and see if we can figure out, what order pair collection of order pairs into the derivative will create this slope field.
Number 2, how is it x over y instead of y over x?
Yeah, so I think that's the hardest part, right? We know it's down to these two here. Let's see. So I think the giveaway here is that if it were C, that means the higher the y value, the steeper the slope. But we don't really see that's the case, right? As we move up on the y-axis, it doesn't necessarily always give us a higher value. But here, x over y would indicate that if I have a large x value, right, the further I move away on the x-axis, I should be getting a steeper slope. And I do see that over here, right? As my x value gets larger, even if my y value is small, my steepness is increasing.
But this, I treat K as a constant.
K is constant, yeah. So no product rule.
I see.
Pretend like it's just a number in front of the coefficient, in front of the variable. Okay, the three, I think for number three, the easy thing here for me to see is that there's a bunch of slope zeros here. And those slope zeros are occurring because I'm subtracting two values, right? Like 2 minus 1 or 3 minus 2 or 4 minus 3. I'm sorry. Sorry, if it was like 2 minus 2 or 1 minus 1 or 2 minus 2, right? That's causing that slope zero. Okay, what I want us to really practice with is problem like number 13, where it's a differential equation, but what throws students off is when it's not x's and y's, right? So just keep in mind that, okay, if I see a strange variable, it's always going to be paired with time. Okay, so t is your x, and then in this case, h is your y. But I'll walk through number 13 with you. But go ahead and read the problem. Let's read the problem together. This is yeah. Okay, so at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of potato is 91 degrees. And the internal temperature is 27 degrees for all time t greater than 0. The internal temperature at time t can be modeled by the function h, that satisfies the differential equation dh over dt equals -1/4 h minus 27, where h is measured in degrees Celsius and h of 0 equals 91. Write an equation for the line tangent to the curve at t equals 0. So this should be an easy problem, okay? So no, we're not having to do any separation of variables. The only thing that dh dt is going to give us is the slope. Use this equation to approximate the internal temperature. So we'll find the order pair, right, which is given here. We'll use the order pair to find the slope, and then we do a point slope form. And then we can use to do linear approximation, right? But here's it's an integer value, so we'll insert that in. The adjustment they have to make is typically we do this like y minus y1, but here we'll just let t be our x and h be our y. So
Is there gonna be like a surrounding temperature problem on the test? Because there's one of eight.
right, if there's a surrounding temperature one, the equation will be given to you. You don't have to create one from scratch. Yeah. So this one is given to us. So instead of y minus y1 and t at x minus x1, I have h minus h1 and t minus t1. My order pair is going to go in place of t1 h1. My dh dt is going to give me my slope. Here's my tangent line equation, and then I'm just inserting 3 to do my approximation. Okay, any questions with part A? Okay, part B, it's asking us to find the second derivative. So I have dH dt, that's my first derivative. But there's a little bit of, I guess, related rates implicit going on here. So if I want to find the second derivative, and I distribute the -1/4 through, so we can kind of just see that there's no product rule here. I'm just applying power rule twice. So dH dt becomes d2h over dt2. What does -1/4 h become? -1/4. Remember, time is a underlying variable here, so times what? dH dt, and the 27/4 becomes 0. Good. So now that we have our second derivative, let's replace dH dt in terms of h, and then we can make our calculations a lot more clear, right? Replace dH dt in terms of h, sorry, in terms of dH dt equation that was given to us at the beginning of the problem. So now we have a second derivative in terms of h. That's a little bit easier to work with, and I can plug in for part B. It says use our answer from part A to determine if, sorry, use second derivative to determine if part A is an under or over approximation, right? So we can plug in our h value of 43. And then we just look to see if it's positive or negative, right? And because 1/6 times 43 minus 27 is a positive value, we know that our second derivative is positive, which means that our tangent line is going to have to live below the curve, which means that since our h graph is concave up, our approximation is an underestimation. Now, part C is where we're going to be doing our solving differential equation. Okay, so here's dg over dt equals negative g minus 27 to the 2/3. So we're going to separate the variables. T's on the right, g's on the left. Okay, so part C is kind of unrelated because they're giving us a brand new equation to work with here. Okay, so try part C. A little bit of use substitution on the left side. Okay, everybody good up to this point here? Separating the variables. Getting it ready for use substitution power rule and power rule on the right side. Trying to remove as much excess information from the left side of that. Eventually, we know we got to solve for G, so anything that we can do on the left side to move to the right side, we want to do that. Okay. We know power rule is coming up, but a little bit of use substitution. But the good thing is that there's nothing that's going to come from du dg, since that's just going to be a derivative of 1. And then once you find your antiderivative, then it's just a matter of what do you want to do next? Do you want to solve for G? Do you want to solve for C? I feel like I'm just going to go ahead and get the C out of the way. So
My order pair is 0, 91. 0 is my T, 91 is the G. Get to my C value. Once I get to my C value, then I can replace the C with whatever number I find, and then whatever algebra I can do to solve for G. So I got to divide by 3, I got to cube both sides, got to add 27. And then once we get to our equation, then it's asking us, based on this model, what is it, the internal temperature? Sorry, the question got cut off. Yeah, what's the internal temperature at time t equals 3? So after we solve for G, then we have one more thing to do, and that is to plug in that 3 into the G equation to get our temperature. I just want us to be comfortable, whether it's X's and Y's or whether it's time and something else, right? That we don't let the variable that we don't see often throw us off, right? That strange variable is just that's just your Y. Okay, last one, number 14. Sorry, yeah, 14. Part A, you're just following the path of the graph through that point, and then part B, tangent on equation. Part C, under or over approximation, depending on concave up, concave down. And part D is where the bulk of the problem is, where you got to separate the variables. Now, there's a little bit of U substitution for part D, so we got to be careful going through that. Okay, so let's see if we can finish up 14 in the next 5-10 minutes.
What if mine is like slightly different from like what the slope field looks like slightly?
Let me see. It should be, if you're, I think this is going too far because you're just going to follow the path of the graph is here. So this didn't go straight down. If we go straight down, the slope should be a lot steeper. So you're just going to cut it off right there. Right. Yeah. I mean, I wouldn't take off any points. Just wanted to let you know.
Okay,
Yeah.
How do you know
Well, how high to make?
the maximum? Is it the same?
You're just kind of following the path of the graph here. It should be pretty close to where I am. You are going to go through that point. So that point is your anchor.
Yeah,
Okay.
I just mean like the maximum.
Right, yeah. I mean, it could be a little bit higher, or a little bit lower than mine, but it should be in the general vicinity.
Yeah.
Yeah.
It's not really.
Right, it's not all the way up, right? It's not all the way up.
Yeah, when you're solving differential equations for part D, I don't want you to feel stressed like, oh, if I missed something, that everything is wrong, right? I mean, there's so many different parts that that if you make one mistake, you know, it's still, I'm still looking at all your steps, and you still earn the majority of your points as long as you understand the basic process, right? You know how to separate the variables, you're applying the appropriate integral rule, you know you got to solve for C, you know you got to solve for Y. If there's U substitution going on, that you're taking those steps, right? So. Okay, how do you guys feel? Do you feel like you're understanding all the problems that you're seeing in front of you? Okay. I have another review worksheets, but it's really for you to work on your own. Tomorrow, I'm going to start a new unit on area volume. So I'm not going to dedicate any more time to the quiz review. But I will have a help session tomorrow morning, 7:30, 7:30. Okay. And I'll also send out a link, or a Teams link if you want to join virtually. Friday is also the quiz for my AB students, so I'm gonna have help session for them Friday morning. So, actually, you know what? I can also do Thursday afternoon. I can do tomorrow morning and tomorrow afternoon if you want some additional help. But hopefully, you know, the review sheet that you pick up, I don't have the key for it yet. So I'll have that key for you tomorrow. And also, if I have it earlier, I'll put it online. And so no homework, just want you guys to start preparing for the quiz for Friday. Okay. And then all next week, we're going to do area volume, but no assessments. Okay. And then we'll have the area volume quiz the Tuesday after you come back from break. Okay, all right, go get your votes and then pick up a review worksheet too.
Yeah, and I can add later. Next year. I'm shit. That's the next year. Okay. I sent it to the schools. So. Or you got it. It was like. That's not like a. It's further, I was thinking it too.